My name is Gregg Lebovitz. I'm with FP Complete, and we are in the business of bringing commercial Haskell to the market. We formed about a year ago, a year and a half ago, by our CEO, Aaron Controller. He came from Microsoft. He was an executive, and he oversaw the Visual C++ program there. So we have a good bit of experience with tools. And in my talk, I'm going to talk about the tools that we built. You won't hear the word monad. You won't hear anything about the details of the code that we've implemented. I'll try and keep this at a high level and talk about the experience that we had in building the products. So our product is a commercial IDE for Haskell, and it includes a development platform and a deployment platform. And unlike some of the other tools that have been available, it is built in the cloud. And I'm going to try and just give a little example here before I continue talking about it. And this is my profile on the FP Complete site. How many people have gone to the FP Complete site and used some of our products? So the FP Complete site is broken into a number of different products. The main view that you see when you join our site, and you have to register for an account to actually create content, but you can just browse over anonymously and look at the content we have. We have a tool that allows you to create tutorials and embed code in those tutorials, and instead of just displaying the code as you would in other platforms, you actually get to run it. So the code is live, you can edit it, and you can interact with the tutorial. The next product that we came out with and that we released this fall, and in fact we're really announcing at the CUFP, is the IDE. And it extends the School of Haskell by allowing you to actually create projects in Haskell and edit them. And it's a web-based tool. It's very easy to use. There's no setup, there's no download. And you just click on your project and you're in the IDE. And there's a number of really cool features about this IDE. One is that it's going to compile as soon as you bring the program up, and if there are any errors to be found, they'll be displayed to you immediately. So if I go in here and I put in some syntax errors, they appear at the bottom clearly. An XXX in the middle of my program is not legal. The other things about the IDE is that it will give you suggestions for how to write better code. And once you get done writing your application, you can go into a deployment manager, and you can actually release your code to a running server and share it with other people. You actually can deploy it as a full running console application or a web application using one of the popular Haskell frameworks. We have full Git integration. You can save your project to Git. You can clone your project from Git, and you can do merges and branches, etc. And there are two ways of using this. One is you can access a repository in an external Git store, either GitHub or your own private repository if you support Git with SSH. And you can import projects by cloning them from our repository to bring them into our IDE. So what I'm going to do is spend a little bit of time of how we built this and how we got here and why we did some of the things that we did. The first is to talk about what our goals were, and they are to increase the adoption of Haskell. Haskell is a great language. It has a great ecosystem, a large community of very, very smart and prolific people who generate lots and lots of useful code, and we want that to be available to people who are in the commercial world where they can take advantages of the benefits of functional programming and the benefits especially of Haskell. So we want to make Haskell more accessible. We want to offer, and we do offer, commercial grade tools and support of those tools in the environment. We want to simplify the whole process of developing Haskell applications and then give back to the community by supporting the projects that are out there, leveraging them to make our products better. So the Haskell Center, our development platform, released at the beginning of September, is a web development tool for building and deploying applications in Haskell. The advantages are that there's no struggle set up. You don't have to download anything. You connect to the site, you register, you get an account, and you start coding. There's no code to download to your system. It runs right in your browser. It has full integration with the help systems available through Haskell. That's Haddock and that is Hugel. And it's very, very, very easy to integrate with all of the tools that are already available in Haskell. There's a Haskell backend. It's doing the project management. It provides developer feedback, as I showed. It will either give you errors or it will give you hints on how to write better Haskell code. It has an integrated build system that you can essentially click and compile and run. And it has cloud-based execution and deployment, so once your application is built, you can deploy it directly into the cloud. And I throw in typos to keep everybody awake, so you'll see a couple in here. But the cloud allows faster product evolution, and we've shown that by starting with the School of Haskell last February, and we've been deploying continuously new versions of our framework over the past number of months. Getting better with each release. So we've been on, during the beta, a 2-week release cycle, and we will continue fast roll out of features over the next few months and the coming year. So in 2013, we released, in March, the School of Haskell. We released our first version of the IDE in September. We're coming out with a lighter version that is for personal use. That'll be a lower cost version of our IDE, and that's coming out the beginning of October, so a couple weeks away. And then over the next few months, we will concentrate on making our tools better and to release a version that will be able to run behind the firewall off of the cloud for the people who want more security on their own environment. So the UI is a web-based tool. We built the entire framework for the tool in a web framework called Yesod. The author of Yesod works for our company and continues to evolve that. We were able to use Yesod as is. We've added very little to the platform in order to build our product. We have lots of library supports that Yesod brings with it. The UI uses JavaScript, and the backend is done using Haskell. What's really surprising is that very few issues surfaced. We've had a couple of bugs here and there that we had to chase down, but the development effort actually went very smoothly. And it's a tribute to the capabilities of Haskell and the strong type safety. The challenges that we faced as we did the development were really outside of the scope of Haskell, but Haskell helped us fix them. One of the challenges is to deal with the amount of JavaScript code that we had to write for the front end. And I'll show in a minute that Haskell helped us solve the problems around that. We developed a stable set of libraries. With the quick evolution of libraries in Haskell, we wanted to have a number of libraries that are version compatible so that they could just be used. You don't have to install them on the platform. You can just import them and run. We wanted compiler integration. What that means is that we partially compile the program and have all of the information about the program, such as the abstract syntax tree, available, and then we use that for things like finding the location of identifiers where they're defined, so we can do quick jump to, we can spot errors, generate them on the fly, and such. Integration with Git and we wanted it running in the cloud so that people who haven't used Haskell before would have easy access. And then once you built them, you can deploy them. We also had to do billing integration in order to charge for our product, and that was one of the challenges that we faced. For the stability issues, we switched to using FP for the JavaScript. That is a DSL in Haskell that implements a type-safe DSL for JavaScript, and once we started doing that, most of our JavaScript issues went away, and it allowed us to focus more on the features than bugs. We created our own repository called Stackage. It's actually managed by the library authors. It's a system of contributions, but the authors work to make sure that all the versions of the libraries work together, and packages are compatible. And we provide commercial support on that for our customers. For code analysis, we actually are using the GHC library, and the library is running in a separate process that tears the program apart as it compiles and makes all of the information available. And that way we can access that tree, the abstract syntax tree, and information about the program, to report errors, to find locations, to find where identifiers are, get details about types and identifiers. So one of the things I didn't show is that if you hover over or click on an identifier, it shows you that identifier's type. And we also support autocomplete, and we pull that information out of the tree so that the syntax tree, so you have that available when you start entering information into the IDE. And we do the same for lint. We make available the API and use the library to analyze our code. So some of the challenges that we face are in building a front end is responsiveness and stability. Sometimes you run into issues where if you combine the front end of the GUI or the web browser with the analysis tools, then the analysis tools will cause a sluggish behavior. So we separated those into two separate processes, and we do the code analysis in one process, and we do the UI in another. This allows us to continuously compile without impacting the reaction time of the program to the user. So this is what it looks like when it's in its graphical form. So one of the other challenges we faced is in a cloud-based environment, you need to run the applications in the cloud, and that requires infrastructure so that you can create private little isolated containers for users to have their code that isolates them from one another and also keeps them from getting access to the underlying system. And we used LXC to create these containers. And the containers really are used for every part of the online application. So when we talk about creating a GHC backend that's going to be running over the code, that's in one of these containers. If we're going to deploy an application into the cloud, that's going to be in another container. And the containers have essentially the underlying operating system, the libraries that are necessary to run, and any of the support services. And it provides ephemeral storage for while you're running your program, which means, implies that someplace we have persistent storage to save the user state so that they can use it later and bring it into a container for running. Containers are run in a distributed fashion. For the IDE, we're using a shared model, so we have multiple IDE instances running on a single host. Those containers have the complete operating system, but for efficiency, they actually are links back to the tenant host and using the actual libraries and operating system that's installed, so that the overhead for a container is very, very low. And this allows us to create these and tear them down very quickly. All of the user sandboxes are in these isolation containers. It loads from persistent storage. The persistent storage that we use is S3, and this is where the user's programs, the Git repository is, and all of the state settings about where the user was and how their project is configured. For managing projects, we do that visually. The project gets built as you create files, and they get placed in the project settings for information about how to build each individual file. The projects are stored in Git repositories in S3, and in that repository is also a definitions file that gets created as you create the project. Of course, you can clone a project from an existing Haskell project, and we will read in the existing Cabal file, and we will decompose that into a project and save all the pertinent information in the definition file. So essentially, you can go from one project format to the other. And in the future, we will enable the export of the internal projects back into some external form. To use Git, we created a Haskell library, GitLib2. This allowed us to have type safety and a little bit more robustness to the Git system. It isolates some of the issues with the Git libraries that we found as we were building the application. And it also allows us to have multiple Git backends. So we have a Git backend specifically for GitHub, and this allows us to manage the keys and put your key in your project so that the user doesn't have to be cutting and pasting public keys around. You can also access private Git repositories, and then we have another Git repository that's stored in S3 that's part of your project. And over time, we'll add more backends. There's been requests for Mercurial and a couple of others so that people can use systems like Bitbucket to store their project. For building projects, since the code is already being pre-compiled continuously in the back end, the code can be quickly converted into or generated into bytecodes, and you can run that right within the IDE. That allows not only to get at the information, but to quickly run the code in a container. And there's a separation of where your code runs and where the IDE runs, so if your code crashes, it doesn't take the IDE down with it. For deploying projects, we took this container infrastructure and we added to it all of the information and services necessary to run a Haskell application. This includes not only the libraries, but also management and configuration. We use a number of different services to do that. Keter is used to run Yesod applications, but we also have a full chef implementation that allows you to have configuration management within your application server. And the application server is offered as a separate product that's running right now in AWS, and you can deploy your application into either a shared container or deployment application server, or you can deploy directly into a dedicated FP application server running in a dedicated Haskell instance. I'm sorry, a dedicated AWS instance. The last challenge that we faced was billing system. We discovered that most of the billing companies out there who are First Tier, First Data, or CyberSource, or one of the many others, are enterprise focused and they use SOAP APIs, and we ran into some challenges because the SOAP API for Haskell, the SOAP library, is not complete. So we had to use existing libraries that are C++ based, that, for instance, GSOAP on Linux, and we ran into some issues in getting this to work. We had to build an FFI for it. We had to build a C binding because GSOAP uses C++ and the FFI requires C. Fortunately, when we did mappings between the Haskell data structures and the GSOAP data structures, it was relatively easy since GSOAP returns all of its data as strings, and we would do the conversion ourselves as we brought it into the Haskell data structures. We ran into some limitations with the way GHC, Cobble, and Linux Loader work that required us to do some hocus pocus tricks, but we were able to get that working, and we plan to share the experience of that at a later date. So